Resources and techniques. SIMD design overview. SIMD systems have two main components, as introduced in section 2.0. These are the control unit, also known as the sequencer CPU, and the processing elements. The sequencer CPU controls the flow of the SIMD system, including the passing of instructions, the PE network, and storing and stepping through the main program. The PE is where the bulk of the computations are carried out. The system can be seen as a standard CPU, the control unit being the sequencer CPU, and the arithmetical logic unit being the PE network. However, this isn't completely accurate as the sequencer CPU has basic ALU functions and the PEs have some control functions. The connections between sequencer CPU and the PE network are laid out in figure 15. There is a single instruction bus connecting the sequencer CPU to all the PEs. Each PE receives the same instruction from the sequencer CPU. Each operation cycle, the PEs in figure 15 are connected in a 2D grid network. Each PE has access to its immediate neighbor. The reason behind the arrangement will be further explained in section 4.2. There are three main factors to consider the designing SIMD system. Processing element designs, PE network topology, instruction flow. With any electronic system, there is a trade-off between simplicity and cost. This is very important in the design of the PEs in an SIMD system. The more complex the PEs are, the more operations they can perform. However, complexity adds cost in SIMD, bearing in mind the major cost is the size of each PE. The larger each PE is, the fewer PEs can fit on a single chip. There is then the trade-off between having less PEs capable of more advanced operations or more PEs with less capability, allowing increased parallelization of operations. This project focused on adding a number of advanced features to the PE design